dear students. I hope for all of you are very fine and staying safe at home. So students, today we are going to discuss Ncert class 8 mathematics chapter 1 rational numbers introduction part 2. So this part, what we will discuss about the associative property of rational numbers, distributive property of rational numbers, at the same time role of 1 and role of 0. So let's start. Here first of all we will start the associative property of addition in case of addition of rational numbers. So take any any rational numbers first. So let's A, B and C be any three rational numbers. What I am saying, A, B and C. A, B and C. Any three rational numbers such that if we add them, A plus B plus C, A plus B plus C, if it is possible, A plus B whole plus C. In this order, if we can add them and calculate them, if the result be same for both the cases, then we can say that the rational numbers are associative under addition. So let's check by giving some examples. First of all, if we take whole number, rational number as whole number, if we take then A plus B plus C 2, let's 3 and 4, and taking simple. So 2 plus 3 plus 4, is it equals to 2 plus 3 plus 4? Yes or no? Yes, of course. Why? Because 2 plus 7 is equals to 5 plus 4. Both the cases give the result 9 because they are equal. So that means A plus B plus C equals to A plus B plus C. In case of whole number dissatisfying, whole number are also rational numbers. If you take by any integer also, it will be equal. I am going to take some fractional examples for you. So let's check. Suppose 2 by 3, there be any fraction and you are adding them by minus 5 by 4 plus plus 3 by 5. So let's add them. So the result becomes 2 upon 3 plus 4 5s are 20. 4 5s are 20. The LCM gives you 20 and minus 25 plus 12 be result. After 2 by 3 plus 20 minus 13 by 20. So minus 2 by 3 plus minus become minus 13 by 20. So result becomes 60 be the LCM, 40 minus 39. So it will become 1 upon 60 the result, which is giving now. This is at A plus B plus C whole. So I am taking here the next side, the right hand side, A plus B whole plus C. Where A plus B, 2 by 3 plus minus 5 by 4 minus 5 by 4. I am taking them in the second bracket. And plus C, what is C? 3 by 5. As there was minus, so I have taken in the bracket, so equals to. So 2 upon 3 plus minus become minus 5 upon 4. And you see there plus 3 upon 5. Plus 3 upon 5. So what is there? The 4 3s are 12 will be LCM. 4 2s are 8 minus 5 3s are 15 plus 3 by 5. The result is giving 8 minus 15, that is minus 7 by 12 plus 3 by 5 is equals to LCM becomes 60 minus 35 plus 36, and the result is 1 upon 60. See carefully, both the cases 1 upon 60 the result is. That means rational numbers are satisfying this condition a plus b plus c whole is equals to a plus b whole plus c. If this condition is satisfied, then we say that rational numbers are associative under addition. So both the cases we are seeing that the results are equal. That means they are clicking or the satisfying this condition. This is the associativity of the rational numbers in case of addition. That means we can say that rational numbers are associative under addition. So let's go for the another operation, that is called the subtraction. In case of subtraction, we see that subtraction. Except just we have to change the sign here. The condition will be the same, only the symbol be changed. Here minus, minus, minus and minus. If it is possible, a minus b minus c whole is equals to a minus b minus c. If it is possible, then we can say that the rational numbers are associative under subtraction. Let's check by taking some examples. So we are taking, let's clean this. First of all, we are taking a whole number or some integers that will be easy to you. Suppose I am saying as whole number 5 minus 3 minus 2 is equals to 5 minus 3 minus 2. Are they equal in the both sides? I am taking the left side as 5 minus 3 minus 2 as the 1, 5 minus 3 as the 2, 2 minus 2. Simply here 5 minus 1 is equals to 4 and 2 minus 2 is equals to 0. Where they are not equals, they are not equals, they are not equals. So we are saying that in case of whole numbers, it is not clicking. Whole numbers are rational numbers, but the condition they are not satisfying. So that means rational numbers, that is whole number and non-associative under subtraction, as well as rational numbers. In case of all the rational numbers, it will not be possible to satisfy this. So we are taking by fractional numbers. Suppose 3 by 4 minus 4 upon 5 minus 5 upon 6. Suppose we are taking this. So what the result be give for this case? So 3 by 4 will be there minus. So the LCM of them 5 into 6, that is 30. 4 6 are 24 minus 25 is equals to 3 upon 4 minus 1 by minus 1 by 30. The result is giving this, and after that you can say that 3 by 4 minus plus by 1 by 30. 1 by 30 is equals to 4 and 30. What is the LCM between them? You know that the 60 is the LCM. It is the 15 fours are and 13 twos are. Both the cases, the result is giving that. So after that, 4 15s are, the 15 threes are 45 plus 13 twos are the twos are. So it will become the 47 upon 60. So you see there 47 upon 60 is the answer. So if we go for the right side, what the result is giving for? 3 by 4 minus 4 by 5 minus 5 by 6 as, so I will be taking a minus b whole. So 3 by 4 minus 4 by 5 minus 5 by 6. So a minus b minus c. So 4 5s are 20. 4 5s are 20 here. So 3 5s are 15 minus 4 4 is 16. Minus 5 upon 6 will be there. So here minus 1 upon 20, minus 5 by 6 is there, and the results of 20 and 6, you know, the result LCM becomes 60, and 23 are, so 3 1s are 3, minus 3 here, and minus 16 are 12, 10 feet, so 50. So result is giving that 53 divided by 60. Here both the cases, the number, the results are different. That means they are not equal. They are not equal. We have seen that A minus B minus C whole is not equals to A minus B whole minus C. In case of subtraction, rational number are not satisfying here. That means they are not equal. Rational numbers are not associative under subtraction, we can say. So I think it is clear for all of you. I think it is very much clear to all of you that are the rational numbers associative under subtraction? Yes or no? Yes. Rational numbers are not associative under subtraction. I think it is clear for you. So now we are going to check for the another operation, that is the multiplication. Multiplication. Here also we will take any three rational numbers such that A, B, C. If we multiply them in this order, that A into B into C whole is equals to A into B whole into C. If we can express A, B, C in that product in this manner, in this order, then if both of them be equal, then we can say that the rational numbers are associative under multiplication. So let's check by taking some examples. And if we take any integers, then minus 2 into 3 into 5 is equals to minus 2 into 3 into 5. Are they equal or not? So let's take individually. So here minus 2 is equal into 3 5s are 15 is equals to minus 6 into 5. We are taking left and right side. So 15 to the minus 30. Here minus 30. Both the cases the results are giving same. So that means we can say that A into B into C whole, there is A into B whole into C. Both the results are giving the same, then they are equal. That means rational numbers are associative under multiplication. We are saying we have taken the integers. If we take some fractional numbers, so let's check by taking some fractional numbers, are they satisfying this condition or not? So 2 by 3 into 3 by 4, suppose we are taking, so let's take in prime numbers, prime, 5 by 4 by 7 by 9, 7 by 9, suppose we are taking. So let's multiply them. What the result is giving. So 2 by 3 into 5 into 7, 35, 4 9s are 36. So if we cancel out them, so it will become 18. So 35 upon 18 3s are 54. 35 upon 54 will be there. If we take this order, so 2 by 3 into 5 by 4 whole into 7 by 9, and the result gives 2 5 is 10 upon 4 3s are 12 into 7 upon 9. We see that 2 5s are, if we cancel out here also, it will be about the 2 5s and 2 6s are. If I cancel out them, 5 upon 6 under 7 by 9. Here 5 7 is 35 divided by 6 9 and 54. Here 35 by 54, here also 35 by 54. That means both the cases giving the same results. That means they are equal. That means A into B whole into B into C is equals to A into B whole into C. So in case of whole number, rational numbers, we are saying that the rational numbers are associative under multiplication because they are satisfying this situation. So we are saying that rational numbers are associative under multiplication. Now we are going for another operation, that is the division. So let's check by taking some examples in case of division operation. So let's take some any three rational numbers such as ABC in the A, B and C, so that A divided by B divided by C, if possible, is equals to A divided by B whole into divided by C possible, then we can say that the rational numbers are associative under division. So let's take by taking some examples. So let's minus 5 is divided by 3 divided by 2. So just taking some integers. So what the results is giving, and here what is this minus 5 divided by 3 and divided by 2. That means we have taken three rational numbers, any three rational numbers. Here integer we have taken minus 5, 3 and 2, minus 5, 3 and 2. So A is minus 5 and B is 3 and C is 2. So let's minus 5 divided by 3 divided by 2 whole is equals to minus 5 divided by 3 whole divided by 2. So let's check if both the sides are equal or not. So minus 5 divided by 3 divided by 2, it's not possible. So 3 by 2 let's take. And here what is this? Minus 5 upon 3. Minus 5 upon 3. And minus 5 upon 3 divided by 2 here. So f is divided by 2. Let's keep it. So here what can I do? So 5 into 2 by 3, it will be changed. Reciprocal is equals to minus this, it will be changed by half multiplying. In case of this minus 5 2s are minus 10 divided by 3 is equals to minus 5 upon 6. Here both the cases they are not equal, so we can't give equal sign. Here will be not equal, not equal. So we can say that this is also not equal. So if you want to take by any fractional numbers by P by Q form exactly, so let's see by them. So this is not equal, it is clear to us. So let's take by taking some fractional form. So 5 by 7 divided by 7 upon 9, and I am taking another one, that's 6 divided by 8, 6 divided by, suppose I am taking 11. So any numbers you can take. So what is possible here? If you want to take a negative number also, you can use here, no problem. Baby. Suppose I am taking this one as the negative. So let's take. So and here will be the order 5 by 7 divided by 7 by 9, 7 by 9. It's divided by 6 minus 6 by 11. So be careful here about the calculation. Divided by here. So 7 upon 9 into 11 by minus 6 will be there. Here will be 5 by 7 into 9 by 7 divided by, that is the minus 6 upon 11. So 5 by 7 be there, divided by 6 9 is a 54 and 11 7 is a 77. So I think this is clear to you, and equals to here will be 49, 9 5s are 45, here divided by, it will be multiplied as its reciprocal 11 by minus 6. So if you want to cancel out here there may be, because 3 2s are, so it will be minus 2 if you cancel out this minus 6. So 3 2s are, 3 15s are. So result is giving, that is 49 2s are, that is 98, and 15 1s are 15, and 51 is 15 is 16, 165, and the negative will be go to the upside, because if we multiply by minus to the numerator and denominator at the same time, then it will be the minus 165. This minus is gone to the upper side. How is it possible? We are multiplying minus 1 to both the numerator and the denominator. So denominator will be positive and numerator becomes negative. So minus 165 upon 98 is the right side is showing that. But if the left side, what is the saying? Left side is saying it should be the down one. I have taken here. So what is saying this? So 5 by 7 into, it will be minus 54 upon 77. There is no any cancel out, so we have to multiply directly. That is equals to 7 sevens are 49, 9 carry 4, 7 sevens are 49 plus 4, that is 53 here, and 5 fours are 20, and 5 fives are 25 plus 2, that is minus 27. So minus 270 by 539, and here we have got this minus 165 by 19. That means they are not equal. So in this order, we are very much easy to clear that. It is clear to us that the rational numbers are not associative under division. If you take any rational numbers and then that is the condition is not satisfying. So rational numbers are not associative property under division. I think it is clear to all of us. So after these few terms, we have to know that role of 1 and role of 0. First of all, I am saying the role of 0. What is the role of 0 here? The role of role of 0. What is the role of 0? In case of rational numbers, here, if we take any rational number, suppose a, take any rational number, suppose a, and if we add this 0, or if we add these rational numbers to 0, both the cases we see that the result nothing but the a itself. That means if 0 is added to a rational numbers or a rational numbers added to the 0, then both the cases the rational numbers remain unchanged. It will be same. There may be the negative or positive, no matter. We know that already. We've learned it in the earlier classes. For this case, we say that 0 is the identity element. It's called the additive identity. We say that 0 as the additive identity. Additive identity number, additive identity element for the rational number. So 0 is the additive identity for the rational numbers. We have to must clear the additive identity. So if you want to check anything, suppose I am saying that 6 plus 0 equals to 6. No matter. If I am 0 plus 6 is equals to 6, that means it is unchanged. When we are adding a number to another number, if the result is that the number is unchanged, for which number the number unchanged, that number is become the identity. Here 0 is the identity, because when we are adding irrational numbers by the 0, then the numbers become unchanged, so it is not changing its value. So that's why we are saying that 0 here is the additive identity. From here there is also a word or a terms come from this condition, from this situation, that the additive inverse. What is this? Additive inverse. Additive inverse. What do you mean by the additive inverse? Additive inverse are nothing but if two numbers numbers, any two numbers, rational numbers are adding and the result is giving 0, then we say that both the numbers are additive inverse to one another. So if a plus b equals to 0, that means a equals to 0 minus b, that means a equals to minus b. If in this condition, that means 5, and if the additive inverse of 5 is minus 5, because 5 plus 5 plus or minus 5 is giving 0. How? Because 5 minus 5 is 0, 6 minus 6 is 0, 7 minus 7 is 0. That means additive inverse of 5 is minus 5. Additive minus of 2 by 3 minus 2 by 3 is nothing but the 2 by 3, because they are giving 0. So both of them are the additive inverse of one another. That is, the additive inverse of 2 by 3 is minus 2 by 3. Additive inverse of minus 2 by 3 is 2 by 3. So that means it is clear that additive inverse of a is minus a. Additive inverse of x is minus x. That means the sign will be changed. Prime value, it will be unchanged. It will be same. Only the sign will be changed. Positive, negative, plus 5, minus 5, plus 6, minus 6. That is 2 by 3 minus 2 by 3. So I think it is clear that the additive inverse, what do you mean by the additive inverse, what do you mean by the additive identity, and clear that rational numbers, in case of rational numbers, the additive identity is 0, and the additive inverse, if any two rational numbers are adding in such a manner that if the addition gives the 0, then both the numbers are said to be, both of them are the additive inverse of one another, such as 5 minus 5. 5 minus 5 is equals to 0. So 6 minus 6 is equals to 0. That means 6 is the additive inverse of minus 6, or the minus 6 is the additive inverse of 6. And after that, we will know about the role of 1. What is the role of 1 here? In case of rational numbers, what is the role of 1 here? If there be any rational numbers, we are multiplying the number, or the rational number is multiplying to 1, then we see that the result is also unchanged. Then a into 1 equals to 1 into a equals to a. The result gives the unchanged. The number is not changing its value. So in this case, we are saying that 1 is the identity element. Which type of identity? Multiplicative identity. So what we are saying, that multiplicative identity. What is the multiplicative identity for rational number? That is the 1. We have to keep in mind, very much important is that the multiplicative identity of rational numbers is 1. Why? If we multiply 1 to a number, or any number is multiplied to 1, then we say that the rational numbers is not change that value, change its value. It will be unchanged. So that's why we are saying that multiplicative identity for rational numbers is 1. From here we have another terms, that is the multiplicative inverse. What is that? Multiplicative inverse. What do you mean by multiplicative inverse? If there be any two rational numbers, if we multiply them and the results or the product is giving 1, then we say that the both of the numbers are the multiplicative identity of one another, such as a and b. If we multiply them and the result is giving 1, then we say that a is the multiplicative inverse of b. If it will be clear, a is equals to 1 by b, that means a is equals to 1 by b. It will be clear, 2 into 1 by 2 is equals to 1. That is 2 is the multiplicative inverse of 1 by 2. and 1 by 2 is the multiplicative inverse of 2. If I say that 5 by 6 into 6 by 5 is equals to 1 also, because 5 and 6 will be cancelled out, so that means the 5 by 6 is the multiplicative inverse of 6 by 5. That means 6 by 5 is also the multiplicative inverse of 5 by 6. So here is the multiplicative inverse and multiplicative identity. We have cleared this, and here multiplicative inverse is also said as the reciprocal. What is that? Reciprocal. Reciprocal of the numbers. Reciprocal of the numbers. I think it is clear to you that what do you mean by the multiplicative identity, multiplicative inverse, additive identity, additive inverse, and the reciprocal. What is the reciprocal of 6? Reciprocal of 6 is the 1 by 6. What is the reciprocal of 2 by 3? Reciprocal of 2 by 3 is 3 by 2. That means it will be changed in denominator and numerator. Denominator becomes a numerator and numerator becomes denominator in case of multiplicative inverse of the reciprocal. So students, now we are going to discuss about the distributive property of rational numbers. First of all, distributive of multiplication over addition. Distributive of multiplication over addition, we will discuss about it for the rational numbers. Let any rational numbers a, and it is multiplied to b plus c. Then for this distributive property for rational numbers, it will be a into b plus a into c. It will be ab plus ac. For case of subtraction also, we can say that the minus will be there. In case of subtraction, if we say same time subtraction, then it will be a into b minus c is equals to ab minus ac. If you want to check out, I am taking some examples. Suppose 3, 4, 5, any numbers you can say. Suppose 3, 4, 5. 3 whole into 4 plus 5 I am multiplying here. So the result is also be equals to 3 into 4 plus 3 into 5. How is it possible? The left side I am saying that 3 into 9, because 4, 5, 9, and here 12 plus 5 3 is 15. So 9 3 is 27, and here also 27. We see the left side and right side both are equal. That is a whole into b plus c is equals to ab plus ac. In this order, here a into b plus c is equals to ab plus ac. This condition is satisfying there. So this is the distribution. A is distributing. A as the multiplication here, and it is distributing under this over this addition. So this one. Similarly, we can say for the minus, that is the subtraction also. How? If we take any this example also here, so 3 and 4 minus 5 and equals to 3 into 4 minus 3 into 5. How is it possible? 3 into, this is a minus 1, and here 3 4 is a 12, minus 3 5 is a 15, and here 3 into minus 1, it will give the minus 3, and here also 7 minus 3. So we see that both the cases are equal. That means this condition is satisfying. A is distributing over the distributive over the multiplication over subtraction, multiplication over subtraction in this order. If you want to take any fractional form, then you also be clear that about it. Suppose I am taking for you some fractional forms to clear your idea. Suppose 1 by 3. 1 by 3 is multiplying here. Suppose it is 2 by 5 plus and 3 by 7. I'm saying that. So what will be here according to just this one? So 1 by 3, this is 3 1, and here would be 5 7 is 35, 7 2 is 14 plus 5 3 is 15, and the result becomes 1 by 3, 35 into it will be the 29. So 29 happens 1 3 5s are 15 and 3 3s are 9 and 9 and 10 105. So it is for the left side. If we distribute these among over addition, then what it will be? It will be this into this, this into this. So 1 by 3 into 2 by 5 plus 1 by 3 into 3 by 7. So 2 by 15 plus 3 will be cancelled and 1 by 7 will be there. So 15 7 is 105 and 2 7 is 14 plus 15. So we will get 29 by 105. In both the cases, we see that 29 by 105. So that's why we say that this condition is satisfying for when A is multiplied to B plus C, then AB plus AC will be the result. That is called the distributive of multiplication over addition. In case of subtraction, if you give here the negative sign, then it will become also negative. Here also the negative. 14 minus 15 will be the minus 1. Here also be the numbers, you will see that it will be the 105 and the minus 1 by 105. Here you will see the minus, and here also you will see the minus, and it will be minus, and it will be the minus 1 by 105. Both the cases will be the same. In case of subtraction also we see that it is holding this is the rules for the distributive or multiplication over addition and the subtraction. We have to keep in mind, if A, B, C are the three rational numbers such as A holding to B plus C, then the result becomes AB plus AC, this one B, because A is as the multiplication, it is over addition. When we means, then A is going distribute among B and C, between B and C. A is distributing between B and C. If there be any more numbers, also be distributing. If suppose B plus C plus D, then AB plus AC plus AD, then AB distributed among two, between two, or among more than two. So I think it is clear for the distributive property of multiplication over addition. In case of distribution of distributive property of rational number, in case of division over addition or subtraction also we can prove it that similarly. Suppose B and C, B plus C divided by A. I mean A will be distributed between B and C. If there be more than any two numbers also, I have taken here two only, minimum one. So if it will be B by A plus C by A, like this, B by A and C by A. This will be, yeah, because A is distributing over addition. In case of subtraction also, that is B minus C, when we divide by A, then it will be B by A minus C by A. Only the symbol minus and plus there. If you want to take any examples, suppose I am saying that about 5 plus 3 divided by 2. So it will be 5 by 2 plus 3 by 2. It will be, but I am saying for the left side. So 5 3 8 divided by 2. What will be the result? 4. If we go for the right side, then 5 by 2 plus 3 by 2. So result becomes 2 as the LCM. 5 plus 3 is equals to 8 by 2. That is the 4. That means both the results are the same. That means if we use here the distributive property, division over the addition, we can find out this. If we take the negative numbers also, then here only the subtraction also, minus will be there, and the result will be there. 5 minus 3 as the 2, 2 divided by 2 will be 1. Here also minus, so minus is, sorry, so the minus is there. So 5 minus 2 gives 2. So 2 by 2 here, it will be the 1. So for this, that means both the cases 2 and 1 and 1, both the cases they are equal. So we have discussed already distributive property of division over addition and subtraction. We have taken here only whole number, but you can take any types of numbers for rational, exact P by Q form also, fractional form also. You will see that the results are in both the cases they are equal. That means they are satisfying the division distributive of division over addition and subtraction. So from this chapter, students, we have learned already the definition of the rational numbers and some properties of them, the closure property, commutative property, associative property, and the distributive property over of multiplication over addition and subtraction, and division over addition and subtraction, and at the same time rule of 1 and rule of 0, that is the additive identity and the multiplicative identity, additive inverse, multiplicative inverse, and the reciprocal. So today I am ending this lecture or the class. We will meet on the another day for the another class. So stay safe and well.